Write down number 3 in 4,302. The answer is going to be 300. Make sure you write in words. Okay. Write down an even cube number. So a cube number is a number that you times by itself 3 times. So 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2, which is 4. Times 2 again, which is 8. I could have had 8. Let's do it again. 3 cubed is 3 times 3, which is 9 times 3 again, which is 27. I can't have that. 4 cubed, 4 times 4 is 16. Times that again is 64. I could have had 64 as well. There's loads of them I could do. Right, here's a list of numbers. 7, 10, 25, 42, 13. From the list of numbers, write down a multiple of 3. So a multiple of 3 is any number that's in the 3 times table. So 3 is not there, 6 isn't there, 12 isn't there, 15 isn't there, 18, no, it's not there, 19, 20, 21 is not there, 22, 23, 24, 24 is not there, 25, 26, 27, 27 is not there, 28, 29, 30, 30 is not there, 31, 32, 33, no, 34, 35, 36, no, 37, 38, 39, no, 40, 41, 42, oh look, 42 is here, happy days. There are 29 children in a class, 13 of the children are girls, 1 of the children is chosen at random. Write down the probability the child is a boy. So we need to work how many people are boys. If there's 29 in total, we've got to subtract it by 13. Okay. I know it's calculator paper, and we'll do this by hand anyway. 9 minus 3 is 6, 2 minus 1 is 1, so 16 people are boys. So the probability is going to be 16 out of 29. I'm not going to count it down because it doesn't ask me to count it down. There are 3 boys and 3 girls on the school council. Alfie, Denise, Brian, Emily, Cliff, Frau. Teacher wants to choose one of the boys and one of the girls to do a meeting. List all the possible combinations. Now I always go for a sample space diagram. So I'll put Alfie, Brian, Cliff for the boys. And Denise, Emily, Freya for the girls. This is Alfie, Denise. This is Brian, Denise, Cliff, Denise, Alfie, Emily, B-E, C-E, F-A, B-F, C-F. It's just a nice way to make sure I've got all of them. This is actually an acceptable answer, but I'm just going to write them down anyway. So A, D, B, D, C, D, A, G, B, so A, E, B, E, C-E, and F-A, B-F, C-F. If you wanted to show off, you could write these individually, but I just don't want to. Simplify. I'm going to put a circle on my x's. 4, 5, 6, 7, which means I've got 7x. And I've had different colour pen, I'd use that. -2, -6. Now, people get confused with your minus numbers. But it's just like -2y's and -6y's. It's actually -8y. Don't get confused that a minus and a minus makes a positive. That's only true if you're subtracting negatives, if you're multiplying. In this case here, we're actually adding negatives, so it's just -8y. Expand, do 2x times 3, which is 6x. And 2x, this is not an x, this is a minus x, so it's actually -2x squared. Dylan and his friends went to a cafe. Dylan brought himself a cup of tea, brought his friends a cup of coffee. He paid for a £10 note, he got £4.61 change. How many friends does Dylan have? Right, so let's do it logically. He paid you a £10 note. If he got £4.61 change, we subtract them. This works out how much money he spent, minus 4.61. Okay, so £5.39p. We know how much a tea was, so let's subtract that tea. Bear in mind I'm putting 0.65 because this is still in decimal. So minus 0.65, which means I've got £4.74. So we know that he spent 79p each on each of his friends. So if I divide this by 79, and then you see that's obviously wrong, and that's because I didn't put my decimals. So let's type it in there and actually put 0.79, and then you got 6, which is a nice lovely answer, which makes loads of sense. First 5 terms of a sequence: 4, 11, 8, 5, 2. Write down the next term of a sequence. Okay, let's check to see if there's a common difference, which is always good. 14 to 11 is 3, but it's going down, so it's going to be -3. 11 to 8 is -3, good, -3. -3, so we know it's going down -3 each time. So 2 minus 3 is -1, so it's going to be -1. explain how you got your answer. You can just say the sequence is going down by 3. Okay. If you wanted to be ask 20 students of year 7 and 8 what pet they likes best, this table gives information about the results. Draw a suitable chart for information. We can choose whatever chart we want. We can do a pictogram, we can do a frequency polygon, we can do a bar chart. I'm going to do a bar chart because that's what everyone chooses. I'm not using the whole paper because it just won't fit on my page. My biggest number is 10, so I need to check how much space I've got. I've got 1, 2, 3, 4, 5, 6. Okay, that tells me I can go down in 2s. 8, 6, 4, 2, 0. Make sure this is nice and even scales. Okay, draw a straight line. I'm using a protractor, which is naughty. I should really be using a ruler. Okay, and on the bottom I'm going to put cat. Then we'll leave space. I'm going to put dog, leave a space and put rabbit. Draw a straight line. It's important that your bars are the same length and that your spaces are the same length. Like cat for year 7 is 6, 7. Draw that down. For cat is 4 for year 8. Interesting. Dog is 8. And it's 10. Rabbit is 5. She is in between 5 and 6, yeah. And 6. Okay. Let's label this. Let's say this is the amount of people. This is animals. Oh, you can't see it. Now the only thing that people might forget is that I haven't labelled these. So what I'm going to do is I'm going to shade one in. I'm going to have to put a key. Now key is important because you need to know which one's year 8 to year 9. So I'm going to put key, draw a box, put my lines. I'm going to say this is year 7. And I'm going to put a box without any lines. I'm going to put year 8. As I said, you could obviously put 3 bars and make these year groups and put the animals next to it. Either way is fine. I'm actually going to give it a title just to be safe because titles are good, even though it's not always requested in the mark scheme. So I'm going to put favourite animals. Done. Has a scale of 1 centimetre to 25 kilometres. Distance between cities of Edinburgh and Bristol is 500 kilometres. What's the distance of scale on a map in these two cities? So it's really 1 to 25 is the scale, kilometres. This is 500 kilometres. So we need to know what this 1 is. So I need to know what do I times 25 by to get to 500. It's a calculator paper, so I'm doing 500 divided by 25, which means I have to times it by 20, which means this side I times it by 20. 1 times 20 is 20, so my answer is 20. Robin is describing a shape to her friend Lily. Robin says the shape has 4 sides, only has 1 pair of parallel sides. What shape is Robin describing? Now it only has 1 pair of parallel sides. So let's draw it. Only 1 pair of parallel sides. I'll join them up. Okay, let me mark my parallel sides. What shape is that? Okay, it's obviously trapezium. Okay, and just for the sake of argument, let's say I drew this, and that's the only pair of parallel lines. That's still a trapezium. These two aren't parallel, so it doesn't make it a parallelogram. Anyway, I digress. Lily then describes the shape. Lily says, the shape has 4 sides, has 2 pairs of equal opposite sides. The opposite sides are parallel. Robin says there are 2 possible shapes. Is she correct? Now the mark scheme is a little bit weird because you can say yes or you can say no. So let's do one. So let's say no, she's wrong. No, she is wrong. Because if it has 4 sides and 2 pairs of equal opposite sides, it could be. And of course, we have to prove that there's more than 2 possible shapes. So it could be a square. Even though a square has got 4 sides that are the same, they are 2 opposite sides, and opposite sides are parallel. It could be a rectangle. It could be a rhombus. Or it could be a parallelogram. And just to be clear, a rhombus has all sides the same. A parallelogram does not. A rectangle we still know what it is, and a square is like that. Oh, but I could say Yes, she is right, yes. And if you say yes, then you only have to name 2 of the shapes, which I slightly disagree with, but the marker team says it's allowed. So, okay, yes, it could be a rectangle or parallelogram. Now, because it's a mark scheme, I would probably go for this answer here, because the mark scheme is quite new at the moment, and this is essentially the correct answer. But just to be clear that it could also be the other one at the moment. Grid, draw a graph of y equals 3x minus 2 from the values of minus 2 to 4. Grid's drawn, minus 2 to 4 is there. Okay, we need a table of values, so I'll put x and y. I'm going to make my table of values go down. Now it's set to minus 2 to 4, so minus 2, minus 1, 0, 1, 2, 3, 4. Typically we don't need all these numbers. We only need 3 of these to be correct, but I'm going to be thorough. Right, 3x minus 2 means I times this by 3 and I minus 2. So 3 times negative 2. 3 times negative 2 minus 2 equals minus 8. My calculator doesn't know the difference between the minus button and this negative button, by the way. Most decent calculators do. Negative 1 times 3 equals minus 2, equals minus 5. 0 times 3, 0. Minus 2 equals minus 2. 1 times 3 is 3, minus 2 is 1. 2 times 3 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 4 times 3 is 12, minus 2 is 10. Okay, let's apply it. Now, because there's nothing here, we know it's going to be a straight line. If this is not a straight line, we know something's wrong. Minus 2, minus 8, minus 2 there, minus 8 is down here. Minus 1, minus 5. Here. 0, minus 2. So, minus 5 is there. Silly me. 1, 1, which is here. 2, 4, which is there. 3, 7, which is up here. 4, 10. Good. Get a straight line. I still haven't got a ruler, so I'm still using my protractor, which again is naughty. Okay, there you go. There's a straight line. Now there are other ways to do this. You do have a gradient intercept method, where this minus 2 is your y-intercept, and this is your gradient. Now I'll be careful for using this method. I'd always go for a table of values, because your table of values will work for every single thing. But if you want to do it this way, your minus 2 is your y-intercept, which is here, okay, which I would have already marked. Now your gradient of 3 means for every 1 you go across, you go up 3. Now you've got to be careful here, because my scales, my x and y are different, but it still works. For every 1 I go across, I go up 1, 2, 3. For every 1 I go across, I go up 3, and you'd mark them and you'd put them out. On grid, reflect A into the mirror line. Now it's good your mirror line isn't your axes, it's actually this one here. If you want it to be smart, this is actually x equals minus 1. But I haven't got tracing paper. Normally you trace it and flip it over. So I'm going to do it the other way. I'm going to count the distance, which is 1, 2. Some of you one's going to be 2 away, which is here. This one here is 1, 2. So it's going to be 1, 2 away. This is 1, 2, 3. 1, 2, 3 away. That point there is 1, 2, 3, 4 away. So it's got to be 1, 2, 3, 4 away. Okay. Sometimes people link them up in the wrong way. Just make sure you don't. Again, you should use a ruler. Have a look. Does this look like that? It does, so I'm right. Right, it says fully describe a single transformation on maps B onto C. Right, so it's B onto C. Now we think about our transformations. You've got rotation, reflection, enlargement, translation. It's bigger. It's obviously bigger. It's going to be enlargement. So we write enlargement. Okay, you'd obviously write anything, but can't. Now we need to find the scale factor. So I'm going to do the bottom bit. This is 3. This one here is 1, 2, 3, 4, 5, 6. So you know 6 divided by 3 is 2. So it's going to be a scale factor of 2. And you can test this. 1, 2, 3, 4. Scale a factor of 2, my height's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Done, we know. Last thing is we need a point of enlargement. Now, normally get all your corners, do your ray lines. So this corner, they correspond. These two correspond. This, and normally be on a grid, it's not, it's just got letters P. So you have to say at point P. In fact, that P was a bit of a clue. Okay, there's 3 answers. Teacher asked Therese to find the value of 2n squared minus 3n where n is 3. Here is our working. 2 times 3 squared minus 3 times 3. 2 times 3 is 6 squared minus 9. What mistake has Therese made? Well, it's always going to do something with BIDMAS, these types of questions. So first of all, there's no brackets, indices, division and multiplication. Remember, these are equal weighting. Addition, subtraction, these are also equal weighting. No brackets, indices, so n squared, so the 3 squared. She hasn't done 3 squared first, so I'd write she needs to do 3 squared before 3 times 2. Okay. The teacher then asks Megan to find the value of 2n squared minus 3n where n equals minus 4. It's all working. 2 times 4 squared, okay, minus 3 times 4. She did 2 times minus 16 plus 12. Okay. So again, we do the BIDMAS. There's no brackets, look at your indices. Now, it's actually with your indices again. It's because minus 4 squared does not equal minus 16. It equals 16. Because when you times your negative by your negative, it makes a positive. So I'd put minus 4 squared is 16, not minus 16. It's a list of ingredients for making 20 gingerbread man. Okay. 350 grams of flour, 10 grams ginger, rah, rah, rah. Right, Sue has all these ingredients. Right. She wants to make 60 gingerbread man. She has not got enough. Work out how much more of each ingredient she needs. So first of all, I need to work out how much it is for 60. Okay. Now, if this is for 20, we know for 40 we're going to times it by 2, for 60 we're going to times it by 3. So I'm going to times each of these ingredients by 3. 350 times 3 is 1050. 10 times 3 is 30. 100 times 3 is 300. 175 times 3 is 525. 60 times 3 is 118. 1 times 3 is 3. Okay. Now, some of these ingredients she's got enough of, some of them she hasn't. Okay. So this is what she has. This is what she needs. So we need to work out the difference. Okay. Now, all of these are in grams, apart from the egg. So all of these are in grams, apart from the egg. Okay. Now, all of these are in kilograms. So this 1 kilogram isn't actually 1 kilogram. Well, it is, but it's 1,000 grams. It means when we do our subtraction, it's a lot easier. So we need to subtract these from that. So it's 1050 minus 1,000. So 1050 minus 1,000, which equals 50. So she's 50 grams of flour short. Okay. 30. Well, she needs 30. She's got 200. She's fine with that. She needs 300, but she's got 500. She's fine with that. Got 525. She needs 600. She's fine with that. That one there, syrup. That's one that she's going to need. So it's going to be 180 minus 100, which equals 80 grams of syrup. And the egg is just 1 egg. These are all ingredients she needs. Okay. Next bit. On a different day, Sue wants to make 50 gingerbread man. She has no eggs. She works out that she needs to buy at least 3 eggs. Explain why she needs to buy at least 3 eggs. Right, so, on one we know that 2 eggs is, but 1 egg is for 20 people. Okay, now, because 1 egg is for 20 people, we know that half an egg is for 10 people. So if she needs for 50 people, needs to times them both by 5. So she knows that 50 people is going to be, so 5 times half is 2.5. So I'm going to buy, she needs 2.5 eggs. And I'm going to say shops don't sell half an egg. Fraser bought a phone for £180. He sold it for a profit of 22%. How much money did Fraser sell the mobile phone for? Essentially, this is a decide what type of percent the questions are, because sometimes people just rush into it. So it's essentially it's a percent increase question. Okay, Now I am a big fan of ratio bars. I know people don't like it, but so here's my bar, 100% to top. He bought a phone for £180. Okay, he made that 22% profit, which means this is now 122%. Now I want to make up 122% of 180. Now you might know your shortcuts to do it, but I always like to do it a long way, especially because this is a calculator paper. Always like to work out what 1% is. So to do that, I've got to divide both sides by 100. 180 divided by 100, 1.8. Now I know 1% is £1.8, but I need 122%. So I need to times this by 122. Times 122. Which equals £219.60p. So my answer is £219.60. Use your calculator to work out 43.2 plus the square root of 99.05, all of it divided by 0.193. Now I've got a decent calculator, so I'm just going to write in exactly as it looks. 43.2 plus the square root of 99.05 divided by 0.193. Right, so this on my calculator looks exactly like that. There's nothing misplaced. I'll just press equals. So I'm going to write this down. Tell me why you can't see it. 275.400967. But let's say you haven't. Let's say you've got a rubbish calculator and I can't type it in. I'm going to type in the top and I'm going to type in the bottom. So 43.2 plus the square root of 99.05. Okay, so now my numerator is now 53.152386665. Okay, and then my bottom is still going to be all of this divided 0.193. Do not round anything. Yeah, if I've lost this from my calculator, I'm going to have to type this all in again. But I haven't lost it, it's there. So I can just do divided by 0.193. Got exactly the same answer. Okay. Right, write your answer to significant figures. That's good. Right, my first significant figure, my second one, so this one here I'll round. Because it's a 5, I push it up. So this now becomes 280, and I don't care about the rest. 4x plus 3 equals 7 minus x. I need to get my x's on one side, I need to get my numbers on the other. I've got loads of options. I'm going to add x. It's always best to add your lowest value of x, but of course it doesn't matter. These cancel out, which gives me 5x plus 3 equals 7. Minus 3 to both sides, these cancel out. 5x, 7 minus 3 is 4. If there's 5 x's, I want to do the opposite, times them by 5, which is dividing by 5. These cancel out. So I've got x equals 4 divided by 5. Some of you might just panic now and go, I don't know how to do 4 divided by 5. Apart from the fact it is a calculator paper, so you could just put in your calculator, but 4/5 is an acceptable answer. So here I'm just going to put 4/5. Neil, Craig and Keith are cousins. Their ages are in the ratio 17 to 14 to 9. Craig is 42 years old. Right, so 17 to 14 to 9. Neil, Craig and Keith. Craig is 42 years old. So you want to know how do we get from 14 to 42? Okay, so I'm just going to do 42 divided by 14. Okay, which is 3, which means we times it by 3. Okay, so we have to times them all by 3 now. 17 times 3 is 51. 9 times 3 is 27. So we know that Neil is 51 and Keith is 27. So Neil is 51, Keith is 27. It measures a length x centimetres of a piece of string is 3.5 centimetres, correct to the nearest millimetre. Write down the error interval for x. Now if we think about 3.5 to the nearest millimetre, so this 0.5 is, you've got to think about your upper bound and your lower bound. My upper bound is 3.55, because any values below this will round to 3.5. My lower value is actually 3.45, because 3.45 and above would round to 3.5. So I need to put 3.45. Now it can equal 0.45. X. Now this one here can't equal it. 3.55. Okay, so this is your answer. 3.45 is less than or equal to x, which is less than 3.55. 100 adults who ask how to keep fit. Each adult goes to the gym, runs or cycles. 45 of these adults are females, 30 of the 52 adults go to gym are female, 35 run, 9 cycle. How many females run? Now you could do this as a frequency diagram, or you could do it as a two-way table. I'm going to do it as a two-way table. I have a previous video how to do it as a frequency diagram. So we've either got gym, run or cycle. Okay, so we've got females or males. The thing I always forget to put is the total, so I need to put a total in. Let's think I've got 45 of these adults are female. So 45 will be here, because it's total, okay? 30 out of the 52 adults who go to the gym are female. So this is gym. So we know it's 52 in total, and we know 30 are female. Okay, 35 adults run, so that means here, 35. 9 men cycle. How many females run? So the females, so we really want this one here. Okay, now we just do this one here, must be 52 minus 30, which is 22. Okay, whichever one's going to work out. Oh, I forgot there's 100 people, which is my total. Now I've got that, I can work them all out. This must be 100 minus 52 minus 35. So 100 minus 52 equals minus 35 equals 13. Now I can get this one here by something plus 9 is 13. So 13 minus 9 is 4. Okay, now I could work out those two, but I don't need to now. I've got enough information to work this missing one out. So it's going to be 45 minus 4 minus 30. 45 minus 4 minus 30. So my answer is 11. So my actual answer is 11. But just for hell of it, I'm going to work the rest out just to see if it all fits. This one here, I'll do 35 minus 11, which is 24. And this is a total, so it's going to be all three of these added together. 22 plus 24 plus 9 equals 55. And let's just double check, because this proves if I've done all of this right. If these two equal 100, I know I'm right. They equal 100, I know I'm right. Happy days. As I said, the answer is 11. 300 seeds in a packet of flour. Right, each seed will grow into white, yellow or red. Probability of a seed growing to a white flower is 0.62. I'm going to write that down. 45 of the seeds are expected to grow into yellow flowers. One of the seeds is chosen random from the packet. What's the probability they'll grow into red? Now we need to know the yellow seeds. Now it's 45 out of a total of 300. Okay, so that's a chance of me doing to the yellow. Now I need to change that to a decimal. Okay, so I can do 45 divided by 300. Okay, S to D, which is 0.15. Now we know that if we add them all together and we subtract upon 1, that's all my events. So my red one must be 0.62 plus 0.15. All of this 1 minus. So I'll set it in this really silly way. 0.62 plus 0.15. So altogether that's 77 over 100. Yeah. Or 0.77. And obviously I've got to do 1 minus 0.77. Which means my answer is 0.23 chances of it going into red. It's quite a confusing question. On a school trip, the ratio of number of teachers to students is 1 to 15. Number of male students to female is 7 to 5. Work out the percentage of all the people on the trip that are female students. Give your answers to whole numbers. Now it's a bit confusing because we need to do something with the ratios and then we need to change them into percentages. Now it would help me out massively if I could make them into one big ratio. And this is what I'm going to do. My 7 to 5. I know if I add them up, 7 plus 5, I get 12. Now the 12 represents all of my students. Now we know that it's 1 to 15, okay, and this is teachers to students. If I can make these two students to the same number, then I can write this all as one ratio. So what I'm going to do is I'm going to times my first one by 15, okay? So 7 times 15, which is 105, to 5 times 15, to 75, okay? Which will give me, which if I add it up, 105 plus 75, which is 118, okay? And this one here, I'm actually going to times by 12. So this is going to be 12 to 15 times 12 to 118. Now I can now combine this to make it 12 to 105 to 75. And just to be clear, this is teachers to males to females. Okay, now I could have chosen bigger numbers, but this is fine. Now the question is, what percentage of people are female students? Now it's easy if I change this to a fraction first. So I know there's 75 out of a possible, I'll need to add all of these up, okay, which is 75 plus 105 plus 12, which is 192. Now I need to change this to a percentage. 25 divided by 192 is 25 over 64. Times that by 100. And I press S to D. My answer is 39.006. But it does say give you correct answer to the nearest whole number. So my answer is actually 39. In the space below, use a ruler and a compass to construct a perpendicular bisector of line AB. People forget how to do this, but it's nothing great. You need a compass. Okay. Don't want to go through basics, but put your pencil in so it's like that. Makes it a lot easier to do. If you're not good at using a compass, turn the paper instead of turning the protractor. Right, we're doing perpendicular bisector. What that means is it means cut the line exactly in half. So what we're going to do is I'm going to put my compass at any distance, I don't care what, as long as it's more than half. Put a mark at the top, mark at the bottom, go to the other half, spin it around, mark at the top, so mark at the bottom, mark at the top. Bear in mind that I haven't changed the actual distance there. Okay, it's really important to leave this here. It's really important to leave that there so you get your marks. And then you join both things up. You should use a ruler. I'm still using a protractor for no reason. And this line here, that is actually your perpendicular bisector. This right angle here, which shows perpendicular, and these two lines are exactly the same length if you wish to measure. Here's a graph of y equals x squared minus 2x minus 4. Okay, two questions are here. I've actually written down there just so it fits into my page. Estimate the root of y squared minus 2x minus 4 equals 0. Now equals 0 is actually this line here. So my two roots are this value here and that value there. This one here, okay. X is going to equal, I'd say that's minus 1.2, and this one here is 3.2. And there's my two roots. Now if you wanted to double check to see if it's roughly right, bear in mind this estimate. If I substitute these into that, it should equal to 0. So let's do it. So I've got brackets minus 1.2, brackets squared, minus 2 times minus 1.2 brackets minus 4. So I'm a little bit out, but that's fine. Okay, let's do it for 3.2. I was putting minus 1.2 in brackets just because it helps with my big maths. 3.2 squared minus 2 times 3.2 minus 4 equals again minus 0.16. So I'm wrong, but by the same amount twice. But these two answers are accurate enough. Right. Write down the turning point of y. So the turning point is where this graph turns, which is going to be this point here. Now this point is 1 across, and I'm going to say it's minus 5. So 1 comma minus 5. And the reason why I reckon it's minus 5 because these scales are different to those scales. The diagram shows a cycle track. The track has two straight edges of 40 meters. The end track is a semicircle of a radius of 27. The diameter of a wheel of Ian's bike is 590 millimeters. Ian is going to ride his bike around the track once. How many complete revolutions will the wheel of his bike make? Now, if we think about this, let's say this is his wheel, okay? A revolution, so let's say like the circumference here is a meter. That means from there going all the way around, it will be 1 meter, okay? So we want to see how many times do I spin it all the way around here. This is not the case though, that's just an example. So our first stage is we need to work out how long this track is. Now don't think because it's circles and because it's compound shape we're talking about area. He's actually going around it, so it's actually a perimeter question. So really I know this bit here is 40 meters and I need to work out this curved bit here. Now because this is a semicircle and this is a semicircle, I can add these together to make a circle. So you need to think about what is the formula for a circumference of a circle. Now people go straight to pi r squared, but that's area. So we really want to deal with pi d, and d being your diameter. This 27 is actually a radius. So really what we really want is 2 pi r, because 2 r's is your diameter. So pi times 2 times 27. Okay, I'm doing it on my calculator. Pi, which is this button here, down there on my calculators, times 2 times 27. Equals 54 pi. We can change it and use this number here, but it's quite big. And I'm going to plus 80. Okay, because it's 40 and 40. So now this is my perimeter of the whole shape. Now we need to work out how much is 1 revolution of Ian's bike. So I'm going to draw one of Ian's wheels. Now the diameter of each wheel of the bikes is 590, so there to there is 590 millimeters. Now the problem we have is this is millimeters and they're meters, and that will stuff us up. Now we can convert this at any stage we want, but I always find it easier to convert at the first stage. And it's because if we're dealing with area, a lot of people think 1 meter squared is 100 centimeters squared, and that's not the case. Okay, so I want to change this into meters straight away. So I know 590 millimeters is 59 centimeters, because I know there's 10 millimeters in a centimeter, and I know 59 centimeters is 0.59 meters. Okay, so my diameter is 0.59. I use the same pi d for this, and this is your diameter, so I don't have to do pi r squared. So I've got to do pi times 0.59. I'm going to do it in a calculator, but I know what the answer is. 0.59. Okay, 59 over 100. I'm just going to do it anyway. 59 over 100 pi, which essentially is just 0.59 pi. Okay, oh, I should have written there. So we want to see how many times does 59 over 100 pi go into 54 pi plus 80. So I have to do 54 pi plus 80. All of this, I'm going to put in brackets, 59 over 100 pi. Okay, and I'm putting in brackets just to really understand it. I don't really have a reason to do that. So 54 shift pi plus 80. Fraction 59 brackets over 100 times pi. I know it seems a bit complicated, but it's exactly what I've written. So my answer is 134.686. And I just want to check to make sure the question doesn't ask me a degree of accuracy. It does say complete revolutions. So that's how many times does it go completely all the way around. So that is actually, so I actually have to round down because it says complete revolutions, and naturally you should round this up. So I'm going to say the answer is 134. The front elevation and the plan of a solid are shown on a grid. On the grid, draw the side elevation from direction shown. So imagine it's that way around. Now you've got to think your front elevation, side elevation, this one here, so it's really going to have the same height. And all these marks are actually going to be in exactly the same place. My plan is going to give me a middle width, which is going to be 2. And all I do is just box it all off. Okay, that's essentially your answer. If you want a bit more of an understanding, I'm going to use the front elevation. We'll turn it into a prism. It's sort of like going to look like, oh, I've overlooked my shape. It's actually going to look like that. If you actually wanted to know what the shape would look like, but you don't need to write that in, I've just done it for a bit of understanding. Distance from Earth to the Sun is 1.496 times 10 to the power of 11 meters. Speed of light is 3 times 10 to the power of 8 meters per second. Show that correct 3 significant figures. Light will take 0.139 hours to travel from the Earth to the Sun. A few things why this is hard. This is in standard form, which makes it hard. That is in standard form. This isn't. These are in meters per second. That's in hours. So if standard form confuses you, write this, even though it's been stupid because you've got 11 zeros, or a little bit less than that, put this as a normal number. But I'm not gonna. Now it's talking to us about time. We've got speed and distance, so we need speed equals distance over time. Okay, this is hours, so we want to make time the subject. So times it by times, times it by times. My rule of thumb is whenever you get a fraction, go with the denominator because it's horrible. Speed times time equals distance. I need to get time on its own, so I need to divide by speed divided by speed. Time equals distance over speed. Now, some of you might know this to begin with. Now we substitute in what we know. Now the distance is 1.496 times 10 to the power of 11. The speed is 3 times 10 to the power of 8. That's meters at meters, so that's works. So it's going to equal my time. My time is going to be in seconds on the calculator. Now be careful, because there's 2 ways I can type this in. Right, I'll do 1.496. Now I do have a times 10 button here. If I do times 10 to the power of 11, even though it doesn't look like it's a power, that is a power. Okay, this is my fraction. If I want to do the other way, I'll do 3 times 10. I'm writing 10 in normally. I'm just using my power button for 8. Okay, it doesn't matter which one you use, it should all be fine. So I got 498.6. But as I said, this is actually in seconds. We need to convert these seconds into hours. So there's 60 minutes in a second, so I need to divide this by 60. Okay, to get 8.31. This is minutes. I divide that by 60 again to get 0.13851 recurring hours. I'm just going to put rounded. This is 0.139 because that 5 pushes it up. Okay, next part of the question. One Google is 1 times 10 to the power of 100, which it is. Danish says, when I multiply 1.49 times 10 to the power of 11 by 6.68 times 10 to the power of 9, I nearly get 1 Google because 1.46 times 10 to the power of 11 times 6.68 times 10 to the power of 9. Okay, is she correct? Now, first of all, I'd look at this. Okay, this is actually one, I don't know what digit this is, but it's quite close to a Google. But there is an issue with this, and it's this 99. Think about, where did that 99 come from? I'm going to zoom in a little bit, actually. Where did this 99 come from? Now, he got it by timesing a 9 and an 11. That's not good maths. You'd have to add them together. So really what is... So assuming this is 9, which I have no idea where it is, I'm going to say no, she's wrong. Danish is wrong. When multiplying indices, well, you add the indices. Now, I think my explanation is actually quite bad. So I'm actually going to put on for 10 to the power of 11 times 10 to the power of 9 should equal 10 to the power of 20. That way there, everyone knows what I'm on about. Equation of a straight line with gradient of 3 that passes through point A. Now, my scales are the same, which makes it easy for me. Gradient of 3 means for every 1 we go across, we go 3 up. So I'm actually going to draw this. So I know my first point's here. For every 1 we go across, it goes 3 up. Second point is here. For every 1 we go across, it goes 3 up. So I'm going to draw my straight line. So it makes it a lot easier to work with. Okay, now you want to think about the equation of this line. Y equals mx plus c. M's your gradient, c your y-intercept. Y equals, now my gradient is 3. It's told me it's 3, so I'm going to put 3x. Equally, if you wanted to draw a triangle, I'm drawing a massive triangle. My base is 2, my height is 1, 2, 3, 4, 5, 6. Always write 6 in it. 6 over 2 is 3. Okay, my c is my y-intercept. My y-intercept is this value here, which is minus 1. You know, I put a plus. Okay, so my gradient is 3x minus 1. If you wanted to test it, it will always work. Let's say x equals 1. So when x equals 1, 3 times 1 is 3, minus 1 is 2. 2. Perfect. Factorise x squared minus 169. Now, this has got no common factors. Now, this might confuse people because there's no middle terms. And it's actually what we call the difference of two squares. Now, 169 is actually a square number. And I can prove it to you by doing square root of 169. 13. Now, if you want to be smart, you just know it's going to be x plus 13, x minus 13. Okay? Because that's a square number, that's a square number. Okay? But another way you want to think about it, if I do x squared plus 0x plus 169, I now want two numbers that add, so minus 169, that add to give you 0, but multiply to give you 169. I'm not going to list them all out because there's quite a lot of them, but 1 times minus 169, 2 don't work, 3 times or whatever, and you go all the way down till you get a plus 13 and you minus 13. Because these add to give you 0, but these times give you negative 169. Expand and simplify. 3x times 2x is 6x squared. 3x times minus 1 is minus 3x. 2 times 2x is a positive 4x. 2 times minus 1 is minus 2. I can always put those two together to make it 6x squared. Minus 3x plus 4x actually gives you positive 1x. So I'm just going to write x minus 2. There's your answer.